Good morning, Year 9. This is Pythagoras' theorem. I know we started this before half term, but the idea over the next two lessons is to learn to apply Pythagoras' theorems to two-dimensional problems, to know common Pythagorean triples, and know what is meant by giving an answer in exact form or surd form. And it is the exact form or surd form that I really want you to have a feel for, because that will make a lot of this work a lot easier. So I'd write this down if I were you, keep it on a bit of scrap paper by you all the way through doing this video and all the way through doing the questions, so that you've got something to refer to. For any right angled triangle, we know that the hypotenuse, which is the longest side and it's opposite the right angle, is going to equal the square of the hypotenuse equals the sum of the other two sides squared. So a squared plus b squared is c squared. So let's remember how we did this before half term. Well, the first thing we did was we determined which was the hypotenuse. It's the x, it's opposite the right angle. Then we formed an equation. So we've got 2 squared plus 4 squared is x squared. And then we solved the equation. So we calculated the 2 squared plus 4 squared equals 20. And we said that x equals either the square root of 20 or 4.47 to 2 decimal places. I will accept square root of 20 as an answer because that is more exact and precise than a rounded answer. So this example here, the first thing I do if I'm looking for x is to work out where my hypotenuse is. I then form my equation. X squared plus 3 squared is 7 squared. The hypotenuse always appears on its own. So solve the equation to find the unknown side. And what I do is x squared is 49 take 9, which is 40. So x is the square root of 40, or 6.32 to 2 decimal places. So if I leave it as a square root of 40, I'm leaving it in exact or surd form. So a value written as the square root of a number is known as a surd. Sometimes it's better to leave your answer in surd form rather than a decimal. And if you remember before, when we've done circles, we talked about exact form, which was in terms of pi. Well, surd form's the same idea, it's exact, whereas a decimal form has to have been rounded and thus is not exact. So I want to remind you, when we're doing this work, this is how to set out workings. And I've shown you both ways of setting out workings, for when you're working out the hypotenuse and for when you're working out the shorter side. And I've noticed here I've gone on to surd form and said you can leave it here. If you put root 20 into your calculator, you would get 2 root 5. And what the calculator has done is said, oh, 20 is 4 times 5. I can split that up into 2 surds multiplied together. And I can, if I square root 2, square root 4, I get 2. So my answer is 2 root 5. Notice we haven't bothered to leave a multiplication sign there, so that's gone. The 2 in front of the square root means it's 2 times the square root of 5. You do not need to worry about this last bit here. The fact that I've got 2 root 5 is a spoiler for next year. So that's a pleasure to come. If you leave your answer as root 20, I will be happy with it. So what I want you to do now is to stop the video, have a go at these, see if you can write them down correctly, and just see where you're going. I'm not going to ask for a copy of these, so if you make a bit of a mess, it doesn't matter, but have a go at working them out. So let's have a think. For this first one, the answer would be 10. For the second one, the answer is the square root of 4789, and you might have stuck that into your calculator and got an answer of 60 something. For your third one, your answer is root 2. For your fourth one, your answer is root 44. And that's a surd that will simplify down, because that's 44 is 4 times 11. Your calculator will show 2 root 11. And your last one, your answer is the square root of 20. If you're looking at these and thinking, I don't know where she got those answers from. There will be a separate YouTube video to go along with this lesson where you can actually look at the test your understanding questions, so you can look at them in more detail. Okay, carrying on. What I would like to do is to do exercise 1. There are 2 exercises on this sheet, so don't think when you've got to the end of this you've finished. The pirate question is always optional, but it's quite a fun one to do. And here, these I want to see proper workings. There isn't much. Basically, you'll have 3 lines of working, which is the way that I showed you before on that how to set up working slide. And then the last little bit is some Pythagoras mental arithmetic. We keep writing out the a squared plus b squared plus c squared, fill in our information, rearrange, find the missing size. Sometimes you can just do these in your head, and I'm going to give you that perfect exercise for exercise 2 where there's no workings, just slam down the answer. If you've used a calculator, I don't mind. If you've done it in your head, I don't mind. So here, the height is the square root of 3 squared plus 5 squared. So actually this will give you a shorter form of workings if you wanted to. You could write your workings out in this form. And then the answer to that with the square root of 34. That I don't think is going to simplify down. It's not a square. I can't see a square number that it's made up of. So if we look at this one is the square root of 7 squared take 4 squared. And the answer is going to be, so it's 49 take 16. I can't reveal my answer. My answer is the square root of 33. So if you want to simplify your workings, again, that's the probably. So for this exercise, there is a printed worksheet you can copy down, and all I want is the missing size. So I print off the worksheet and scribble the missing size on each one of these. And then could you identify which of the triangles are Pythagorean triples? That means which of them give a whole number answer. So there are a couple of them that will give whole number answers, and we looked at Pythagorean triples before half term.